Hey guys, cool. So this video we're talking about timelines, né? So we have learned so far, of course, from grade 10 with those simple interest, compound interest, and we can make calculations based on that. I mean, we already did. We spoke about also decaying or depreciation, both a straight line and reducing balance, right? What else? Yeah, I think that's what we have spoken about so far, right? And the thing is, someone can make an investment, so say I put on my 1000 rand, and then after 2 years, I start to work, or maybe like I don't know. After 2 years, say I decide to increase the money that I've put there. I'm like, "Ugh, no man, let me add an extra. Maybe let me add 5,000 rand." So after 2 years, then I add 5,000 rand. Then later on the third year, maybe say the fourth year, there's an emergency, and I desperately need the money. I don't want to go and make a loan, so I'm like, I have investments or savings account that I put money on, so let me go there. So I go there and I withdraw 2,000 rand. Remember now, the initial investment it was 1,000 rand. After year two, I invested 5,000 rand more, right? And then year four, I withdraw 2,000 rand, right? You see that. Then we can ask you a question like, how much money will I be having on my account, say at the end of year six. Right. So now you already understand. What do you understand? You understand that the 1,000 rand that we did put on, it's gonna, there's gonna be interest each year. We're gonna gain some interest each year, right? Yes. And depending on whether we are vying with simple interest or compound interest, calculations will be different, but we're gonna have like interest, right? Now, um, which year? Year, year two, when I add 5,000 rand, we can actually then say 5,000 rand plus the money that I had at that time at the end of year two. So 5,000 rand plus the money I had, we add it up, and then we start making new calculations based on the new amount, right? And then it goes on, goes on, goes on. Then year four, then I stop. I withdraw 2,000 rand. And then now with the remaining balance, I need to calculate how much interest will I have till the end of year six. That is the whole scenario. That is the whole scenario of timelines whatsoever. And or maybe like it's not the whole scenario of timelines. What I want to say is timelines. It helps us be able to visualize these things when it happens. And once you are able to visualize it, you are able to make proper calculations, you see. So we will make a couple of examples, and you guys, yeah, we're gonna grab this thing, we're gonna understand what timeline actually is. So cool. Here's a good example. 60,000 rand is invested into an account which offers interest at 7% per annum, compounded quarterly. This is also something that is very important. Let me see. I think I missed it. There's something I want to add here before we work on this calculation. Just something. Just hold on. Yeah, so I have something beautiful here. So there are these periods that we're gonna talk about, right? We have yearly, like when you read these financial statement questions. Hey, yeah, I'm not talking about accounting materials, but like when you read on when you read your questions, you're gonna hear this a lot. For example, here our interest is compounded quarterly, right? Our interest is compounded quarterly. So this is something you guys are going to hear a lot about, right? So Yeah, so when they said compounded yearly, it's just annually, right? So yeah, and P is 1, which is your period of course. Then if it's compounded half yearly, then it's 2. Compounded quarterly, it's 4. Compounded monthly, it's 12. Weekly, daily, whatsoever, right? So now you can ask a question to say like, why does this matter to me? Like, how does it affect what we have already learned? And I will just show you right now how it affects what you guys have already learned right now, right? Say for an example, so for your compound interest examples, like formulas, formulas, you have A into P 1 plus. Now the formula changes to I divided by M into N times M. Right. And this now becomes the new formula that we use, right? Since here they said P, maybe I can say P also, but P is gonna be confusing because we already have a P. So yeah, I'm putting that M there, right? So yeah, M is actually P, right? If they say compounded quarterly, so you already see in our example they said 7% compounded, 7% per annum component quarterly. So you already know that you're gonna say your 7% 0.07 2 years divided by M, which is 4, and then there you will have a number of years, maybe 5 times M, which is what, which is 4, right? So you get it, yeah? Cool. So just relax, and let us read the question again and actually apply ourselves and use this timeline changes. That also I want to say, ne, this question that I chose, I found it so cool when I saw it, and it neatly addresses two things I want to show you, ne, that there are different ways in which you could solve these problems. You just have to be very, very careful. Ne? You have to be very, very careful here. Cool. So 60,000 rand is invested in an account which offers interest at 7% per annum, compounded quarterly, right? Compounded quarterly. So quarterly, we already know it. It's 4, right? Period is 4. Oh, so this thing, it means like like our interest is compounded 4 times a year, so like we gain interest 4 times a year. Do you understand? And there is damn, this thing makes so much sense even now. It makes so much sense even now, right? So we talk about like how many times the interest have been compounded, right? Ooh, ooh. I wonder. I don't know. It just came to my mind like, it makes sense. This is how it is. So you see, I'm just gonna focus right here. My focus is gonna be here, ne? That's where my focus is gonna be. So 4, ne? So we have this 7%, right? Which is 0.07. We're gonna divide it by 4. Okay. So and that it's going to be what? 0.07 divided by 4. That is 0. Okay, it's fine. Let me just say 700 over 7 over 400, ne? Yeah. So this is powerful. So, and then remember this thing right here. Maybe a different color. I don't know. Let me finish this up. Let me finish this one up. So we're saying it represents how many times did we get interest, or like, yeah, how many times was our interest compounded. So now here we are saying per annum is compounded 4 times, which is right. So now when we take these, we like 7 over 400 plus 7 over 400, plus 7 over 400 plus 7 over 400, because there are 4 times. It's like January, February, March, during March, April, May, June, July, August, September, October, November, December, right? 4 times. So now we take those 7 over 400 I can just say multiply, but I'll just go with the pluses. Plus 7 over 400 plus 7 over 7 over 400 plus 7 over 400. You see what we get? We get 7 over 100, which is 0.7, which is exactly 7%, right? So in a year, the interest we get was like 7%. And yeah, so what I'm saying here, I would say like okay, you guys, I think what's very important is knowing how to apply these things, but also just to know like what does what means and why it means that whatsoever, like also like sometimes when you understand the code, the rest becomes so easy, né? So you see here, oh my god, you see this part here, né? N times m, that's how many times our interest that got compounded. Remember in the previous examples that we did, né? Yeah, in the previous examples, I'm just gonna go there now. In the previous examples we did, just like here, right? We did work on this one, right? And we saw that during the first period, this was just 1, né? In the first period it was 1, right? This is one of the examples we did. And then in the second period it was 2, right? Yeah, because we gain interest at the end of year 1, we gain interest at the end of year 2, and then we gain interest at the end of year 3, right? So it's like, yeah, the number of times at which we will be getting, our interest whatsoever. But yeah, just something I just realized. But yeah, yeah, yeah. Okay, let's now work. So it's 7% compounded quarterly for the first 18 months. Beautiful. So for the first 18 months, right? Remember, a year is 12 months, and then there's another 6 months. That means 1 year and a half, right? So we already know that we have 1.5 years, né? And then thereafter, the interest rate changes to 5% per annum compounded monthly. Now our interest changes from being compounded quarterly to being compounded monthly, right? And then 3 years after the initial investment, after we made 60,000 investment, there is a withdrawal of 5,000 rand from that account, right? And they are asking you now how much will be in the account at the end of 5 years. You see, also, so in my illustration of what is the timeline, what timeline is and how it helps us, I didn't mention also the idea of interest rates changing, because that's why I said this is a perfect example. It's gonna help us. I think after this example, we will be ready to move to the next topic. Yeah, we will be ready to move into the next topic. So let's cook this one. So first thing first, like here, the first thing first, you draw your timeline, né? You draw your timeline. So let us do that. One, 2, 3, 4, 5. Yes. So then I will say this is T0 initial, and then this will be T5. Here we have T1, T2, T3, T4. I'm just saying time 0, time 1, time. But of course, this is year 1. Yeah. Year 1, year 2, year 3, year 4, year 5, right? Yeah, year 1, year 2, year 3, year 4, year 5, right? So initially, what happens? Initially, we made an investment, so there is a plus 60,000 rent, ne? Invested, right? And then now in terms of the interest rates, ne? Here this is 1.5 years, 1.5 years, ne? And then during that time of 1.5 years, I'll just say we have this up until this, right? During that time, the interest rate is how much? 7% PA compounded quarterly, right? And then from here all the way to year 5, yeah, it's now 5% compounded, 5% per annum compounded monthly, right? Then another thing is like at where 3 years later, here 3 years later there's a withdrawal. So then here minus 5,000, that's where the withdrawal happened, and then nothing happens afterwards. We leave the money there up until year 5. So the question is, what amount will be in the account at the end of year 5? Cool. So let's work this out. Né? So the first calculation I'm gonna make is for the from year 1 to year 1.5, right? So during that time, man, this needs, they are bothering me. Yeah, so I had the Wi-Fi on and there were some weird ads coming up there. Cool. We are ready to move. So I'm gonna focus on the 7% per annum component quarterly. Then we make calculations for further. So right here I am doing method 1, the first method, né? We're doing the first method, we'll keep the value, do the second method, compare the answers, right? So for the first method, of course, okay, you're gonna have A. Let me go for blue. A equals to P into 1 plus I divided by M, N times M, right? So our P is 60,000. Interest is 0.07, which is 7%, 0.7. And then come on, bro. Compounded quarterly now, so this is 4. And then we have 1.5, which is N, the number of years, multiplied by 4, right? Compounded quarterly, right? So that is just for the first part. And then yeah, okay. Maybe can I just do this? Then I'll add these things, 1 plus 0.07 over A over 4, 1 plus 0.07 over 4, yes, that's 1.175. And then I think this is 6, but let's see. Yes, it's 6. Yeah, so that is the amount that we will be having in our account at the end of that period. 1.5 years. At the end of that period, that's this. If I do put this value in my calculator, the amount we get here, it will be the amount that we'll be having in our account. Yeah. So now remember that this money is still in the account, so and we still have another 3.5 years remaining, so we're gonna now make calculations for that. Cool. So I want to make this as easy as possible. So this right here, I don't want to put it in a calculator yet, right? Because yeah, I saw some issues when you know, like when you round up the numbers early, and yeah, the values, they don't end up matching up to the exact value you want them to match to, but it's a minor thing. So this amount right here, let's call it A, and then now, okay, I think, yeah, I'm still on the right track. So let's say we call this one A. So now let me calculate A. Yeah, I don't know what to call that, but yeah, it's the A for the remaining period. So the amount that we are investing, it's exactly this amount here, right? This is the amount that we are investing. So it is 60,000. 1, 2, 3, 1 plus 0, 175.6. Remember, this is the amount that we have in our account. Do you understand? I want you guys to understand that. Don't confuse it with what I'm gonna write next, because now what I'm gonna write here is this, right? We're gonna have, or maybe let's do it step by step. Let me say P and then 1 plus, this is so beautiful. This is so beautiful. Cool. So with what I have now, I'm doing the substitution. Substitute P, that is 1 so that is P. Now we have 1 plus I, which is, what is I? I is 5, so we have 5%, right? Yeah, we do have 5%. We do have 5%, so 0.05 divided by, so now remember, what did the question say? The question said we are compounding this thing how? Monthly, right? The interest rate is being compounded monthly, so then we're gonna have divided by 12. We're gonna have 12 multiplied by what? Think about it. 12 multiplied by the remaining duration, which is what? 3.5 years. You see it, ne? Cool stuff. So now when we put this whole amount in a calculator, we're gonna get exactly the value that we'll be having, given that we didn't make any withdrawal. Everything is still clear. So if we don't make any withdrawals, this is the value we will have in our account. So we have to the power of 6. And 12 times 3.5. Right. So the value we get, it's 79,000. La 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 la. So let's write it down. Cool. So that's the value that we get, and now we're gonna go back. So now remember that there was 5,000 that was withdrawn at year 3. So yeah, so now what I am going to do, I'm going to calculate that if this 5,000 we don't withdraw it, Yeah, say like there was 5,000 rand. I just want to see from year 3 to year 5 for that 2 year duration, how much interest will this 5,000 actually have. So to do that, I will say A equals to P, just the normal formula. I am N. Substitution, I have 5,000. 1 plus, remember interest was 0.5. Then it's compounded monthly, and then I have exactly 2 years times 12. I do my math. 5,000 divided by 12 to the power of 24. That is gonna be 24, right? Then I have 5,524.71. You see, so now my final value, because now remember the 5,000 was withdrawn from year 3, né? So for the last 2 years in our timeline, for the last 2 years, the 5,000 was no longer there, implying also even this interest. This is the interest that the this 5,000 that you see here, not the 5,000, 524 rands and 524 rands and actually 71 cents. Money was almost showing me. So that interest, we don't have it because the 5,000 was removed. So we're gonna, because now on here the value we have here was on the assumption that we didn't make any withdrawal. So for us to withdraw all the interest that was gained and the 5,000 as well, we now say perhaps here I will say 1 2 3. We will now say final amount. Final amount will be this A minus this one. Here I'm just creating my own formulas. So we now say 79,000 minus 5,524.71. So the calculator now says we have 79,286.87. We are subtracting 5,524.71. Right, and the value, our final value for this problem becomes what? It becomes 73,762 rands and 16 cents. This is the final value, implying this is the value that the question was asking about. What is the final value, or what amount will be in our account at the end of year 5? Do you see it? Cool stuff. So I hope you guys understood this method, ne? You didn't understand it, go back, rewatch it, and yeah, you will understand it. Now I want to show you the second way in which you could attack this kind of problem, right? Little bit similar, but there is something different. So let's get started. First of all, I'm gonna copy this value because we're gonna use it to compare method 2 with method 1. So I'll just put this value up here, yeah, as our, of course, AF, maybe for final. Yeah, and then I'll remove everything, and yeah, we'll do the math again. No, this one I still need. Delete. Yeah, so the second method, the basics is still the same, né? The logic of starting the problem is the same. We start with calculating our accumulated amount for the 7 2.5% interest compounded quarterly. We have it here. And now we're going to the value that we have at the end, this value right here. We are now in, it's now gonna have a new interest, sorry, for exactly 1.5 years. Because now from this term to T3, it's exactly 1.5. So now we're gonna reinvest it to say we're gonna say okay, let me do the formula first. Cool. Now substitution. So I know P is 60,000. This thing I'm writing here, it's P. Wait, to the power of 6. So that is P. That this thing I have written here, it's P. And then now we have 1 plus 0.05. This is the 5%, which was compounded monthly. And now remember, now before the withdrawal time, it's 1.5 years. Multiply by what? By 12. Ne? And yeah. Cool. Maybe I would say 60. 1, 2, 3, 1.015 to the power of 6. 1 plus 0.05, 12. Such a long number. Wow. Okay, now let me pause right here. So at T3, at the end of T3, before the withdrawal, this is how much money we have. And then now the withdrawal has been made, right? The withdrawal has been made. So I'll say at the end of year 3. No. At the end of year 2, right? There is a 5,000 rand withdrawal. Or you could say at the beginning of year 3, there's a 5,000 withdrawal. Make complete sense. So now this 5,000 withdrawal, because now at that time when the withdrawal happens, this is exactly how much money I have. You see, so I'm gonna take exactly this much money that I have, and I'm gonna subtract 5,000 rand from it, and yeah, that will be my new A. So I'll say A equals to this value. We put it in a calculator. Let me say A3. So I'm gonna have T3. I'm gonna have AT3 minus 5,000. Yeah, so now just look at my calculator. I'm gonna take this thing, punch it there. 60,000, 1.0175. Yeah, 1. Hey, when I said nice. Let me see. Cool stuff. Oh, cool stuff. Wait, close. To the power of 1.5 times 12. Beautiful. So this right here, there's the value that I have, and now I take that value, right? Let me just say this. The value is, or this A3 is 71,756.65 minus 5,000, which is minus 5, 1, 2, 3, which is, we minus 5,000, we end up with 66,757.65. You see it, ne? We have made our withdrawal, and now this is the value of P, or the value of A, how much money we have in our account after we have, withdrew the 5,000 rand. So now, last calculation, we're gonna calculate how much interest, of course, will this amount have till the end of year 5, and we'll be having our final answer. So it's A equals to substitution 66,000 5%, still 12, because it's still compounded monthly. Then yeah, so now we're gonna put that in a calculator. We see what we get. Two times 12, we're getting 73,762.18. So this is the final value that we have, right? Yeah, this is the final value that we have. Let me copy it. We need to compare it to the value we had initially with method A. So, and as we can see, it's exactly, the value is exactly the same. The only difference is by 0.2. That's the only difference, and this difference is caused by rounding offs and all of that, because here I was rounding, yeah, I did the rounding up thing. Yes, I was rounding up. Yeah, so I hope you guys did understand, like, the logic, with these kind of problems. Yeah. What's very important is for you to draw your timeline so that you can actually see what is happening during what time and what is happening during what time. When you have that picture, your calculations becomes very easy. Yeah, personally, I prefer the second method, because yeah, it kind of makes so much sense to me. Like, we did invest, and then before we made the withdrawal, we check this is how much we have, and then from that much we make the withdrawal, continue, and yeah, until we get to the final value. So personally, I prefer method 2, but method 1 also work. Cool. I'm gonna cut this video. I'll record another one where we will just do a couple of examples that involve timelines. Okay, see you in the next video.